Today we're here to walk you through how we use Python libraries to clean and analyze global aviation data. So we began by importing necessary libraries such as pandas and NumPy. Then we defined the column names for each data set for airlines, airports, and route data sets. Next, we loaded our data sets and we handled all information with /n and handled them as none. Next, we inspected our data and checked for missing values. So we use this now to check for missing values, and we use sum to calculate the total missing values we had in our data sets. We converted our numeric columns to appropriate data types, for example, latitude and longitude, and we checked for duplicates in our data set as well. We then went on to get rid of all duplicates in our data sets, and we handled missing values for IATA and ICAO. We replaced all missing values with unknown, and we went on to verify our data types and our missing values after cleaning our data. What I went on to do next was filter out invalid latitude and longitude values. So for latitude, all values outside the range of -90 and 90 were gotten rid of, and for longitude, outside -180 and 180 were also gotten rid of. We printed our new information and we went on to provide a visual representation of our data sets. So we used bar charts to represent top 10 countries by number of airlines, distribution of airports by country, top 10 source airports. And next, we went on to provide a summary statistics of our data sets.
So after getting cleaned data and some visualizations to represent them, we then created a global aviation network dashboard using Python and Streamlit. So from analysis, we discovered that there were thousands of routes and airports, and we were able to uncover some key insights about them, their airline network, geography, and market competition. So we have 5 tabs on our dashboard. The first tab is the Overview tab, and this represents a summary of the statistics of over 7,500 airports and 6,000 airlines and over 67 and almost 67,000 flight routes. And we also displayed the top 10 hub airports based on their connectivity using network centrality. We also have another tab, it's called a network tab. And basically this network tab is just providing some network analysis. And here we are visualizing the global aviation network as a graph. Airports are represented as nodes. These nodes are colored here in different colors, and the node sizes and these colors reflect the centrality. That is how concentrated these airports are at specific places. And this is to help us detect the most influential hubs in the system and potential vulnerabilities they may have. We also have a geography tab, and this is for geographic analysis. So here we have a map of the airport density by country, and we're able to achieve this using Folium, using Python. This is showing us how well certain regions are connected and which ones are under-deserved. So the colors here are displaying the total number of airports here. We also have a business tab, and this is for business intelligence, and it's to help us answer certain questions that we may have about the entire global aviation space. And here we have a graph showing us the airlines, certain routes they've covered. So for example, you can see that Ryanair here, which is an American-based airline, has almost 2,500 routes counts, and United Feeder Service has a little over 1,000 routes counts. And a Chinese airline here, China Southern Airlines, has close to 1,500 airlines. So this should tell you some information, gives you given insights on certain things in their markets, in the airline space. We also discovered that there were just 20.3% active airlines in the entire global aviation space. We also have a search tab, though this is to allow potential users to find the shortest path between airports. So for example, if you want to find the shortest path between JFK and HND, you enter the IATA code of these airports, and you enter the IATA codes for the source airports and destination airports, and this will give you the shortest routes and also give you some insight on the total number of stops you have to make using these shortest routes. So this here is our global aviation network dashboard, which you're able to put together using Python and certain other models and libraries based on the clean data we had from our earlier cleaning and analysis process. Thank you. In summary, we developed two Python-based projects, a Canvas LMS Lite and a Global Aviation Network Analysis Dashboard. Our Canvas LMS Lite, as you saw, was basically a lightweight learning management system that supports role-based access, assignment workflows, analytics dashboards, and simulated communication built with usability, security, and scalability in mind. Our Global Aviation Network Analysis Dashboard was basically a data analytics project that uses real-world aviation datasets to explore network connectivity, centrality, route patterns, and geographic distribution through powerful visualizations and interactive dashboards. Both projects demonstrated the application of data handling, visualization, graphic user interface development, and modular Python programming in solving real-world problems across education and aviation domains.
Hello, so this brings us to the end of our video. We hope you like, share, and subscribe.